Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events and today is one of such events. And if you want to find out more about the events we have, there is a link in the description. Unfortunately, right now, the only event we have there is this one, but actually we have more in the pipeline. We just haven't announced them yet. But this is a useful link, keep this in mind, because maybe you watch this in recording, so when you click on that, you will see more stuff. But yeah, if you don't want to miss out on amazing interviews like the one we have today, do not forget to subscribe to our YouTube channel. You will have notifications about our streams, and then we have a great Slack community where you can hang out with other data enthusiasts. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link and ask your questions, and we will be covering these questions during the interview. And that's all the introduction I have. Now I will stop sharing my screen. I will open the questions we prepared for you, and if you're ready, we can start. You're ready?
I'm ready, yeah.
Okay. This week we'll talk about bringing together research and industry and how explainable and interpretable machine learning and AI fit into it. We have a special guest today, Polina. Polina is a data scientist at SAP. She's passionate about bringing the current machine learning research to business. In her PhD dissertation, she created a framework for churn prediction, and this framework uses organizational trust theory and explainable machine learning methods. We will be mostly talking, I guess, about explainable ML, but I'm also very curious about organizational trust theory. I have no idea what it is. Maybe we will talk about that. But yeah, welcome to our podcast.
Thank you so much for the warm welcome. Very excited to be here.
Yeah, we're very excited to have you here. And as always, the questions for today's interview are prepared by Johanna Bayer. Thanks, Johanna, for your help. So let's start. And before we go into our main topic of interpretable and explainable AI and ML, let's start with your background. Can you tell us about your career journey so far?
So it's maybe also going to be further covered in the industrial PhD, but basically that's I think the biggest element of the earliest element of my journey as a data scientist. I did an industrial PhD with SAP at the University of Mannheim, merging together sociology and data science. I also identify myself as a computational social scientist. And then after the PhD, I started as a data scientist at SAP. And what I do day to day, I think I used to always cover it or like call it end-to-end data science. So basically from the point where somebody comes up with an idea to bringing a productive machine learning model to life and then maintaining it. This is kind of what I can work on, and that's what I cover in my job at SAP. And Alexei, actually, that's an interesting point. I listened to one of your talks recently, I think at a RISE Observe conference, and you're calling it a full stack data scientist. So I learned a new thing, and now I think I can identify with that as well. And one very important point that I have to mention, I described my job, and this is something that I can say publicly, but anything further I should not talk about. So everything I talk about here is me, a private person, not SAP, not an opinion of my employer, just wanting to say that. Okay, so after that, I mentioned that all of the opinions that I voice are my own, not my employer, and that I'm not going to be talking about the actual job that I do, because obviously I'm here as a private person. So that's what I have to mention, just for the clarity of the situation.
So yeah, it's funny that you mentioned this full stack data scientist, because when I first gave this talk like 2 or 3 years ago, it was a thing, because ML engineer and the role of an ML engineer was not yet that developed, and like it wasn't that common, and MLOps wasn't that common either. So data scientists often needed to do everything end to end, and there were, of course, data scientists who specialized more into, I don't know, the business side, or specialized more in software engineering. But now with ML engineers, data engineers, and other people working together on the team, I see that there are fewer full stack data scientists. Yet you say that you are one, and I'm wondering like how many of those of people like you see in the
Are
industry,
still
maybe.
left.
Yeah.
Yeah, I think it's also kind of my impression of what I observe on LinkedIn and how people's career journeys are developing. I think it's getting more specified. So maybe I would be then going closer to the business side and to understanding the business problems compared to some people who develop more this ML ops specialization. So I do see that, but I think it's kind of my roots where in the early career, especially in the PhD project as well, I was the only person managing my own PhD project, and I was facing a lot of points where I had to bring many things together. So that's I think a simple explanation of how I first came to be a full stack data scientist, because in a PhD you're supposed to do many things independently.
Is it a common situation when a PhD student actually needs to do everything end to end? Because I think it is, right? That's kind of the point. Or there is usually help?
I think it really depends. My PhD project was actually an applied project for the company. And there, of course, I faced this duality of, on the one hand, I have the scientific element to it, I have the research, and then on the other hand, I have actual stakeholders and people who would, in the end, be using the model and benefit from it. So, of course, I was also facing all of the things that do not necessarily belong to a PhD project, but there are so many PhD projects, so many industrial PhD projects. So I think I cannot say it's like it's 100% a must, but it was a big learning for me.
So the answer is it depends, right? It depends on the project, it depends on the group where you work, and many, many other things.
But maybe I didn't want to phrase it this way because it depends as an answer to everything. And,
yeah, right.
I still want to try better.
And so actually I wanted to talk more about your PhD at the end, but I think now it's a perfect segue to actually talk more about that. And you said that it was an applied project for the company, for SAP, as I understand. And there was a scientific element, plus in addition to that, there were stakeholders that you needed to manage. So for usual academic PhD, the output would be like, 3 papers and then a dissertation based on these papers, right? But for you, it was different, right? So in addition to the papers, you also needed to deploy a project to show the business value, right? Am I correct?
Yeah, exactly.
Does it make it more difficult? Because you have kind of 2 goals.
Yeah, I think this would be a situation or a problem that every industrial PhD student faces, where on the one hand, you have the research interests, and maybe your university supervisor who pushes you into bringing the research further on, and then the other hand, you would have the industrial benefit, and there might be a bigger or a smaller overlap to if it actually is the same project or if it's 2 completely different ones. So for me, the overlap was rather huge, but of course there were elements that were only in the research part, so only in the output text, basically in the dissertation, and of course a lot of the things that I learned during putting things in production, for example, were not covered in my dissertation, so they were industry only.
So you did not describe in your dissertation how exactly you used the Kubernetes or whatever framework for deploying models. You did not write anything about that.
Exactly. So maybe to get closer to the topic for everybody to understand more what I did, my dissertation was focusing on studying the relationship between a software as a service provider and their customers. Basically, I looked into how the trust is built up theoretically and then tried to see it in reality. And then I also wanted to understand how these trust elements impact the continuation of the relationship. So basically, if you phrase it in a machine learning problem terms, then it's a churn problem. So basically predicting churn was the model. So for the organizational trust things, I think, of course, a lot of things were just describing the theory, so not exactly immediately relevant to the industry. And if you put it this way, actually for the text of my dissertation, how I bring it to production was not necessarily relevant. So it was a tiny part in my defense during the defense where I mentioned that it is actually live, but it's not something that has a chapter or something.
So it was a tiny part in the dissertation, but I imagine for the actual work, I don't know what was your experience. In my experience, usually this is what takes most of the time.
So it was a big learning curve to me because I came from this kind of idealistic perspective, maybe, that whatever insights I generate, anything would be very, very beneficial to the industry. And then I realized that there is just so much more to it, and that a real data science project is actually more complex, and also managing it completely is a big challenge. Yeah, so that was a big learning for me, and I think maybe that's why it was more work as well. So I think maybe a fun story. The first time I was discussing pipelines around machine learning engineering, I was basically at a stage where it's like data comes in, I want it there, but I was not understanding maybe. No, I do, but I was not understanding the complexity of how things in the industry can actually work.
Also, it means that there is an additional risk factor. So for a usual PhD, the risk factor, the typical one, could be that you do not find what you wanted to find, and then like how do you write your PhD if you could not prove that? In your case, I think there was organizational trust theory can be applied to churn prediction, right? So that's one element. And then another element, even if theoretically it works, but then practically, will it, right? And then you kind of need to try. So you have two things that could go wrong, as opposed to usual PhD where maybe it's like less risky. Am I right?
I think so. I had a lot of research showing that it can work, and there are also a lot of interesting studies showing that on other data and translating it into industrial terms. So I think for the PhD there is a lot of risk. Anyways, I would not say that this is more risk in this case. I think it's actually probably at the level of a PhD, it's as much risk as it can get. So it either works out and you get a title or it doesn't. So I think that's actually kind of the same for all PhDs. But I think maybe to turn it into a positive way, it's also a double support, or it was a double support for me, because my supervisor at the university was very understanding of the setup, and was also helping me to find the elements of value that I can get to the company. And then my team in the company was also very, very supportive of my PhD. And I think that's kind of where it all, if it all fits together nicely, then it's actually a lot to learn. And it gives you two things. First of all, the research experience, but then still a lot of work experience as well. And a reality check, to be honest, because I think my original motivation for doing it in the industry was that I didn't want to just write and then put it on a shelf, or just publish something and never know if anybody got anything out of it. And here I actually can see that it is applied, and there is a lot of learning for everybody, including me. But
Was there also, so you mentioned that you had a supervisor from the university side. Was there also a supervisor from the company side?
Not immediately. So it's also different in different industrial PhD setups. Sometimes there is a supervisor. In my case, it was mostly basically the teams that I worked with. They were interested in the project, but not necessarily somebody who would just supervise me completely.
But there were some stakeholders, right? So still somebody from the company side would guide you.
Of course.
And they say, okay, this
Yeah.
is not what we need. This is not what we meant. We want a different thing. And that was like that, right?
Yeah, exactly. So basically, my stakeholders were helping a lot with that.
Mm-hmm. And how did this actually work? Like, were you talking to them every day? How often did you get feedback from them? Were you talking to other, I don't know, team members? How did it look day to day?
So day to day, I think it was just a data science project. So just the data science work that you can imagine, like regular calls with stakeholders. I think that's not that much different from what every data scientist who has business facing roles does every day. And then, of course, a lot of exchange in the team. Again, very typical for data science teams to just talk to each other. So I think also no secret information revealed here. I think what was different for me was that I also had a chance to attend conferences or summer schools. And that was, again, this merging together the industry and the university lifestyle. So basically, I could go to a conference or to a summer school, and then I could bring my ideas from my project and then learn on the go from the research. So that was a very interesting experience.
And by conferences, you probably mean academic conferences, not industrial conferences.
Exactly, academic
like
conferences.
The ones where people publish papers, print posters, and then discuss research.
Exactly.
Summer schools are a lot of fun. So I wish there were more such things, and they're not very common in industry. I guess they're usually for students, right?
Yeah. So also my PhD was partially during COVID. I started, the first year was 2019. So I did summer schools then. And then 2020, 2021, virtually impossible to have like any real life summer schools. So, but I'm also kind of thankful to the situation of being locked down because it forced me to write a lot.
Okay. But did it mean that in addition to your work as a full-time data scientist, you had some extra work because you also needed to write it all down, or it was balanced because your team knew that this is actually your PhD project, so then you could spend time saying like, hey, this week I'm actually working on a paper, so I'm not working on the project.
So it was very balanced, and I think it actually, again, depends on the setup. In my setup, it was balanced, but for other people, also in academia, I think some people work on a project and then on top on their PhD, and then when there are deadlines, you are just like on your own with the deadline, and it's you and your personal time management. I think that's probably shared among all PhD students, not specific to this industrial setup.
I remember when I was getting my master's degree at TU Berlin, I saw the PhD students who all of a sudden realized that the deadline is soon, and then they would just 24 hours, 7 weeks, 7 days per week spend just on writing the paper, and they did not look very good when I met them at the university. They were very stressed.
Yeah, the stress levels, I think it's any PhD at some point. It's just your project and you want to get it out in the best possible way. So shared experience.
So for you, it was an explicit decision that you made that you want to do an industrial PhD project. You don't want to do just a PhD. You want to do it you want to apply this research at the company immediately. How did you come up with this realization? How did you learn that this is what you want to do?
I think so. In my bachelor's and my master's, I was already very interested in doing basically data analysis, but for companies or with data that can bring something valuable to someone. And I did a couple of projects that were also for companies during my master's and in seminar work. And then I realized that I'm interested in a data that just very often is owned by companies. So if I actually want to develop in the area that I think is most interesting for me, then I want to go there. And also this idea of not just putting the PhD on the shelf and that's it. I think that is very important.
So you already had some connection to the industry and you did not want to lose this connection, but you still wanted to do a PhD, right? And then you figured out that you can actually combine the both. You can stay in academia and work on industry projects.
Exactly. And I think both can actually learn a lot from each other. So I still think I would not have done it differently. So I would have done the industrial PhD again if I'm asked again. So
how common is this setup? How common
Sorry?
is this setup? Because, for example, I know that again at TU Berlin, where I studied a long time ago, I don't remember that the group where I was had such direct connection with the industry. So usually maybe the company would give so the company usually gives some money to the group to work on something, and then they give some data. And then they're like, okay, bye, now figure this out. And then come back to us in 5 years, something like that. So that was my feeling how this thing worked. So my question is like, how typical what you had in general is?
I think it depends very much on the industry and very much on the subject of the PhD. So I'm a social scientist by education, by training, so it's very not common for social science, or rather unusual. I think in other disciplines, it's probably more common. Somehow I'm thinking chemistry, but do not quote me on that. I think there it might be more common to have a collaboration. But yeah, if you're interested, so if any of the listeners are interested in finding the PhDs, you can go at least in Germany for the big companies. So SAP obviously has this setup sometimes. Also, I think Siemens, Bosch are offering this. I think the automotive industry in Germany also has this industrial PhD setup. Certainly at the moment in the area of machine learning. So if you're interested, just do a bit of research on their job seeking websites. What I think also you can look at is industry or university websites. Sometimes they advertise such collaboration programs or so industry related PhDs. I think the Technical University in Munich definitely has a page that offers that. But again, it always is a question if you need to find a professor that supports this this collaboration, and in a company it also must fit some project. So I think it's not exactly common for companies to just hire scientists to run on their own and do wild things. But if it fits together, then there are actually more opportunities than I thought they are. So, and as you can see, I'm asked this quite often. So I already did some research and like, okay, what can I recommend? Are there any companies that offer that?
So would you say if I wanted to check what are the possible projects I can do with SAP, what kind of Google query I need to use, like SAP machine learning in industry PhD, something like that?
So I would basically use PhD or doctoral student or doctorate in the search, because I think that's how the positions are frequently advertised. But again, each team can define it in a different way. So I think a query with a PhD student or a PhD research position should work.
Do they require you to speak German, or English is sufficient?
There's so much depends on the company. So again, also the team. I think there is no yes or no here. It's
so it depends, right? So you just
yeah,
find a
it
position,
depends.
and then they probably say if you need to speak
Yeah.
German or not. Okay.
And
Okay, I actually want.
my fingers are like quickly googling. I think Daimler required German for some positions, but yeah, just it's very very dependent on the specific team.
Was your dissertation in English or German?
It is English.
English, okay. Because I know, like in some countries, you cannot write in English. Your dissertation has to be in the language of the country, university, whatever. But I know that in Germany it's not the case. Like in Germany, you can publish either in English or in German. I don't know about other languages. Maybe you can do it in Latin.
Latin, I'm not sure, because in which language would you defend if you are writing in Latin? Not sure, but I think now that the research is basically very international, a lot of universities actually expect you to publish in English. So I think that's what motivates this kind of idea that you can actually submit an article-based dissertation in English as well, if that's exactly the expectation for publication.
I also wanted to talk about the content of your dissertation, and like at the beginning, when introducing you, I said that you were developing a framework for churn prediction that used organizational trust theory and explainable and interpretable ML, right? So what is organizational trust theory? What is that?
I think this will need an episode of the podcast of its own, because it's actually you can look at trust from so many angles. And why I say organizational trust theory is because very often when people say trust, they mean interpersonal trust. Basically, I trust you as a person. But in organizational trust, it's different agents, basically organizations interacting with each other. All of them have people inside. So you can go to this personal trust level, but that's not what I did. So that's why I say organizational trust as a term. And what I used was the ability, benevolence, and integrity framework. I called it ABI. So basically, there are different layers of trust, and there is this more technical trust ability. So in the context of software, that's I believe that this software will work. So let's do. I think let's do an example of Microsoft Office, because I think everybody is familiar with that a little bit. So the technical trust is I do know that this software allows me to do what I need, so like writing or PowerPoints or emails or something like that. And then there is in a long-term relationship between two companies, or between a company and a person, there are these more relationship-based elements, benevolence and integrity. And this is where it goes into a more interesting for me direction. So with integrity is it goes more into this I know that they will be there for me if something goes wrong direction. And with benevolence, it's this long-term support delivery, basically. So integrity happens after you sign the contract, where you don't really know what's going on, but then somebody talks to you and they assure you that it's going to be all right. And benevolence is more like the actual support that you see over time. And why it was interesting for me for the relationship between two companies is before that, you could just like I'm again switching more to people because I think it's more understandable with people. But yeah, so imagine you bought a Microsoft CD disk. I still had CD disks when I was in school. So basically you have this CD disk forever, and that's basically what you know is working. And until you have a completely incompatible system, it is going to work. But let's say you buy it now. You buy it now and it works for some time. And then you have a question, or there is a feature that you bought it because of, and it's not delivered, and you open support tickets and you go to the community website, you ask questions, they maybe don't get answered. So there is a whole lot different of the relationship in the subscription context compared to this. I have this one CD disk and nothing goes wrong until the system gets so updated. So,
Well, it
that's
might
why
go
it
wrong.
grows.
Just there is no way to get support, right? There was no way.
I
Or
mean,
it was
there
not
was
difficult.
definitely a way to get support, but I think it was not as prominent in the relationship. So with the subscriptions, it's actually, I think after I started researching it, I realized that it's actually kind of growing everywhere. Anything that it has a subscription, it can kind of trust it to go for a long time. But if it accidentally breaks or something happens, then you actually will go to the company and ask for help. And this is why it's just so much more relevant nowadays.
And what about the price? Because for me, one of the big drivers for me to change, let's say I use some product, some internet company, and then they decide to increase the price, and then I think, okay, what are the alternatives that might be cheaper? And then I do research, I find a cheaper alternative, and then I switch. Does price have anything to do with trust, or maybe it's like a separate thing?
I think this is not something that I personally researched, but I think also looking at just the consumer. So again, outside of the company's relationship, because there are contracts and there is a lot more governing this. So with regular end users, like let's say I have Spotify and then they increase the price, I think this is definitely a mechanism that goes to this ability again, so kind of to the level before trust. And this is a place where it's actually also harder sometimes to justify the relevance of this relationship, because it can be broken because of some other things. So let's say I use Spotify and then at some point they just don't have the songs that I like anymore. So this is again like this ground reason for why I use this, and not exactly the
Would it be ability, like you expect this software to be able to give you the songs you like, but then all of a sudden they don't have the songs you like, so they kind of violate your trust to be able to provide you with these songs.
And I think in one of the papers that I read, ability was always the most important and the most significant element of trust. So basically, how it goes is ability is mostly consistent over the relationship. So you can imagine if Spotify doesn't have the songs that I like anymore, then even if they're a nice provider, even if they support me so much, I would probably not continue using the service. Hypothetically, they have a lot of songs that I like.
Then maybe the example with price could be related to integrity. You kind of expect that like the price is this one, but then all of a sudden they change it. Or maybe I misunderstood the framework, but could it be related to integrity, or it's more like something else?
I think so. It always depends on how the relationship is set up. And what I mentioned before with the contracts, it's actually you sign the contract and there is like the agreement between you and the company that there are specific regulations about the price change. So it's actually hard to answer this one without knowing how the agreement looks like. And I'm unfortunately not the expert on contracts in this
Wondering
regard.
how many people actually read these agreements before starting using services.
I try to, but I always ask myself, well, would you use the service if, like, what should be in the agreement for me to not use the service? And then when I realize it's not that much, then I just skip. But I actually try to be conscious about that because there are many things that can be in there.
And then how is it related to explainable AI? Because I guess this framework, you use this framework of organizational trust to somehow create features maybe for your model or somehow guide your project. But then there is another component, which is this explainable AI. So how are these two connected?
So I think this is also maybe one of the arguments or one of the ways how I turned to research more in the explainable AI direction. On the one hand, I think in social sciences, it's very common that you have the features and variables, however you like to call them, and then you try to understand how are they connected to the outcome variable in a way. And in the industry, it's very often about just modeling and being accurate, but not about building a theory and trying to show how it works in detail. So when I was starting, I was overwhelmed a little bit by the research on churn that exists. So I tried a lot of neural networks, and I was actually disappointed a little bit because on tabular data, they were not exactly performing perfectly. To maybe understate this, they were not performing at all. And then I turned to the more black box models, so random forest, XGBoost, some of the things that are more classic. And then I started understanding that it's actually, you have the feature importances, of course, but going into this understanding of how the features actually contribute to the outcome and how your model works, this is not exactly a standard element of data science, and or not a standard element of the black box models. So what I actually loved is that I realized that sometimes the stakeholders can feel the same way. So there was also a demand that the model that I'm building should be more than just a score, because the score doesn't really always tell you a story. So I realized that on the one hand, it's something that I have in me trying to explain with the model, but also knowing how it works. But then also that this accuracy-driven or area under curve-driven, whatever metric you have, because for me it was a classification, so these two come in place. This is sometimes not enough for the end users, and that's also what I realized during my PhD project, that actually with the social science background, I'm able to communicate, and this explaining actually helps to communicate models in many ways. So this is how I ended up researching in 2019 everything around SHAP values and Lime and all of the things that seemed so groundbreaking at the point, and now everybody uses those. So I think it was actually very exciting for me to understand that the entire data science community is growing into the direction that feels so natural for me. So that was very, very inspiring and a very good moment. And then, of course, that's what I used in the dissertation as well.
And in practical terms, so for you, it was about discovering the connection between, I don't know, maybe you had different groups of features, like features related to ability, features related to benevolence, features related to integrity, and then you used tools like SHAP values and Lime to determine how exactly these features connect to the outcome. And if a stakeholder asks you, hey, why for this user the score is 0.9, you say, because like they think that our ability is not really good, right? Was it something like that?
Yeah, I think there is also a post on LinkedIn where I show a more public display of what came out of my PhD. So that's the level where I can stay at on this public thing. Yeah, I think for the end users, I basically show several components of how the outcome is modeled, and it's actually very important, and that's also something that I learned over the years of trying to explain models, is that sometimes it also has to be actionable. So integrity per se is, for example, an interesting thing to discuss or to research, but telling the end user integrity is the reason for this and that is not exactly actionable. So they don't know what integrity is. They don't have any options to connect with this. So I also realized that actionability is a very important element during this. And if you look, for example, at the upcoming, there is the first World XAI conference coming up in July, and I'm very excited about going there. There is definitely a group of sessions on actionable, explainable machine learning. So you can also see that actionability is a very prominent trend currently in the research.
What is that?
But also applied.
What does it mean, actionable? Did you say actionable, interpretable AI? Actionable, explainable AI? What does it mean?
Yeah, so maybe a comment on explainable and interpretable. Interpretable is basically more, for me, a technical term. So my model is logistic regression. I can fully see through that. There was another podcast, I think a couple months ago on DataTalks.Club about explainable machine learning, and there you mentioned the glass box models. So that's that. And explainable is more this user-facing. So are you able to explain your models? And I have a metaphor for this. Somehow I got obsessed with cats this year, with cat-like gifs and so on. And there are many gifs with like cats getting out of the boxes and being curious. So for me, explainable AI is all about this curious cats to think about to whom are you explaining and who would be jumping out of the box to ask you more questions. So that's kind of the explainability, and interpretable is obviously an element or an attribute of the model. Yeah, and actionable is more like, so if you have already mentioned this cat in a box, so can the cat do something with what you explain, or is it just a curiosity?
It's actionable machine learning, and then we have interpretable and explainable. So they are kind of different characteristics of a model. So a model can be interpretable, a model can be explainable, and a model can be actionable.
Yeah, and so for actionable, I think the way it is used, for example, within the conference that I mentioned, it's actionable, explainable. So you not only explain, but you also give some insights into what actions can the end users take based on the model.
Which is quite important, right? So if our model gives us a score, a churn score of 0.9, for us it's like, okay, what do we do now with this? Like, doesn't mean we need to send them a promotion to try to keep them, I don't know, our users, or we need to do something else. And so this is a part of actionability plus explainability.
Yeah, so it's also something that's not relevant in all cases. I think explainable machine learning, I'm always arguing in favor of that because it helps you as an end user. It also helps you as a data scientist. It has many positive sides to it. But actionable, I think, is very often maybe an attribute of actually something where the end users want to do actions based on that. So maybe also more thinking of decision making.
Okay. And then you mentioned this term glass box model. So I guess this is the opposite for the black box model.
Exactly.
We have like random forest, which could be a black box model, right? And then glass box model would be, I don't know, logistic regression, right?
Exactly. Yeah.
And then would random forest plus sharp values be a glass box model or black box?
So I think maybe I will mention a couple models that are more complex glass box models before that. So what I'm mostly excited about in the research now are generalized additive models and neural network-based models that are basically additive. So neural additive models or neural basis models are very exciting examples of those. And I have been in the past weeks and months looking at how they compare to random forest and chaff. And I think what I don't know yet is what is the baseline, because basically in the end, we have a way that a neural network would model something. We have a way how a random forest with chaff would model something. But what is the ground truth? And very often we don't know. And with random forest and chaff, for example, the chaff values only try to approximate, so they never really tell you like this is 100% how the model works in every situation. So you still don't get this kind of real see-through glass box feeling of it, but it's still more than just a black box. So I do see that it's definitely not a glass box model, but maybe like
interpretable.
Yeah, I think it's explainable, so it's not interpretable per se, because it's not exactly 100% the model itself that gives you the outcomes or the interpretability.
Okay. So interpretability, it has to be a glass box model, then like a logistic regression model. Okay. Or
for me, yes. I think there are different ways to put it. So basically, I think every person in the field has maybe a slightly different definition of interpretability. I think that's.
But linear models are usually interpretable.
Exactly.
So decision trees probably, right?
Yeah, I think with a random forest, I think technically you could actually go into all of the trees and like learn it all, but sometimes your brain just doesn't have the capacity to do that. So that's where interpretability breaks for me. And there's also a trick with explainability, or a recent research that I mentioned that I like a lot. It's actually, so with explainability, you would say, I have a random forest and chaff, and for each feature, I know what the contribution to the outcome is, so that's explainable. But in fact, when you add a person to this, sometimes it's completely not explainable, because maybe your features are named in a way that nobody can read it, or maybe they're just so not understandable that no human can know what this means. I think this is more commonly applied for computer vision or text, where it's like, this pixel is gray, this is why it's a cat, and this is not exactly explainable how we would put it for humans.
But then for neural networks, I think there are these techniques that show activation regions, like that show like you have a picture and then it shows like highlights the area around the ears, highlights the area around the nose, or like around the areas of the picture that shows that this is a cat, and these are the areas where the neural network is activated. That's why we think this is a cat, right? And this would be an example of explainable machine learning, explainable model.
I think very often, so I'm not an expert in computer vision, I'm more a tabular data person, but for me, when this kind of activation maps are displayed, this is definitely an element that makes it explainable, because of course there is much more in the background that is calculated to just display that, but this display helps to communicate it to humans.
So I just want to summarize what you said to make sure I understood. So interpretable and interpretable machine learning model should be a glass box model. So it should be something like logistic regression, linear regression, generalized additive model. This sort of model that you can look at the coefficients that the model learned, and then you kind of can make sense of this, right? And then explainable ML model can be a black box model, but there could be a method that helps us understand the output, and then we can explain why there was this prediction. And then actionable ML model would be a model that, like, there is a score, and then we know what to do, what kind of action, what kind of decision to take based on this score, right?
Yeah, exactly.
And then there is a question from Satyajit, and the question is an interpretable ML model necessarily explainable as well, or they're like it's not always.
Mhm.
Does it follow from being interpretable that the model is also explainable?
So for me, it does not. And if you're interested, there is a very nice paper. Maybe we can link it in the notes for the episode later on. There is a paper about explainable feature spaces. It's from a research group at MIT, and they are looking into different, basically different curious cats. If you put it in my words. So to whom do you explain your model? And it actually has a very nice visualization of how different explanations may matter for different groups. So if you're talking to a data scientist, for them, an interpretable model is probably explainable because your end user cares about individual features and they know what the features are. And they are also very technically skilled to actually also understand everything that the coefficients mean. If you're looking more in the area of ethics, for example, you have very different backgrounds there. So for some people, they actually want very different explanations for your model than this kind of strictly technical outcome of the interpretable model. Even after logistic regression, you can get very confusing features in, and therefore very confusing outcomes. And then the closer to the end users or to decision makers you get, the more explainable your feature space must be. So it's not enough to just label your features 1, 2, 3, 4, 5, and then put it basically to a decision maker and then tell them, well, 5 is 1, therefore it's 0.9. This is technically interpretable, not at all explainable, not at all understandable.
Okay, so what is explainable for a data scientist is not necessarily explainable for a marketing person, right?
Exactly. Yeah. So
So then for data
always,
scientists, maybe it's true, right? So from interpretability, explainability follows, right? But for the rest of the world, maybe it's not.
yeah, and I think so. My logic is always like think about who you are trying to explain to, and your explainability is always based on your audience.
Then there is a question about trust, but I think it's a different sort of trust, not the one we talked about, organizational trust,
Okay.
but maybe it is. So you will probably tell us. So do you think that explainable AI models can bring trust among customers or different stakeholders?
Yeah, so this is a research direction that's very common now, I think also in computational social science, in AI research that focuses on how people interact with machine learning, not the trust that I focused on. I think, so in the neural Bayes model and the sparse polynomial additive model, they actually test like how comfortable the end users feel when they see the explanations. And I think that's something that gets more and more prominent now. You also see it in the SHAP papers that people test, can people really understand it? And researchers want to know, does it really get nice feedback from the humans interpreting the models? So I think explainability really helps also for to maybe demystify a little bit this machine learning phenomenon where people might think that it's just like press a button and then you have something and you will never know because the machine is smarter than you. I think the machine is not smarter than you, and very often humans and end users have information that the machine doesn't have. So it's actually helping to build trust, in my opinion, but also what it helps to build is this power of people knowing what the machine learned and then adding something on top of this to get the best outcome. And I think it's very interesting that for large language models, for example, also I'm not an expert, but for large language models now there is an increase in demand of where does the information come from? Is it something that the model learned? Can you point to a document where this comes from? So it gives you a more grounded interaction between the model and the end user.
Because you want to know if the model just hallucinated and came up with this out of nowhere, or there is actually a document where this is described, right?
Yeah, so with tabular data and simpler black box models, they do not hallucinate in this way, but with large language models, it just gets more prominent that you really want to make sure that it's not a hallucination.
Do you have a couple of more minutes?
I do, yeah. There's a
Okay,
few
because
more.
there is a very interesting question, and I see that we are running out of time, but I want to ask this question. So this question is from Adonis, and then Adonis is asking, is there a way to track organizational trust? Is there any KPI or metric related to that? Because I was thinking, so when you were describing that, okay, we have this ability, benevolence, integrity, and then we also have this framework from interpretable or explainable machine learning. So we kind of can link all the predictions because we understand that, okay, like these features are related to ability, and we see that more and more maybe users churn because of that. And it would make a great metric that people from executive, like from top management, would really understand. Like, do you see this happening in practice?
So I think what I must say here is trust is incredibly difficult to measure. So what you have is basically a lot of proxy variables, a lot of variables, Alexei, as you said, associated, related to trust. But you can never say it's 100% something that captures trust. And because it's so hard to catch, it's also, I think it's impossible to make it a KPI because in a way, it's just, you can have measurement errors. You never know what's really happening between the people because organizations, as I said, are actually people. So there is a lot of things that you would not want to track. Also, compliance, GDPR, a lot of laws, and just not ethical to track this on a level where you would try to observe it. So I think overall, I would say it's impossible to really make it a very well measured KPI. And when it's not well measured, then probably it shouldn't be a KPI.
Mm-hmm.
That's my point on that.
Other good proxies that at least will give you some indication that, okay, we're losing customers because our integrity is not good.
I think this will very much depend on the company. So each company has very different perspectives on who the customers are. So I talked about Microsoft Office customers and Spotify customers. Of course, you cannot measure it in the same way, for example, for these two products. So it's very different. And I think so. One of the learnings from my PhD was that there is a lot of research in also marketing and relationship studies between companies that show that it's important. And it's important to show that, yes, it is in fact true. There is a role that trust plays in the relationship, but I think it's so hard to measure, and it's so specific that I like that it is a research project for me, but yeah, maybe not exactly a good KPI for companies. And then we talk about the fact that ability, so making a great product, is actually more important than I think we have the response or the answer to that. So
yeah, but
building great products would be a priority anyways.
I guess it is a good idea for another research project, right? Because I can imagine that this could be useful for, or at least I think now. Who knows what the reality is? But I can imagine that for executives it could be useful to see, okay, we're losing customers because of that thing. Let's see how we can improve that thing. But as you said, like if you focus on ability, maybe like other things will follow.
Yeah, and I think there are many people researching churn in many different ways. There are a lot of ways how to look at that.
Okay. I think we should be wrapping up. Thanks a lot, Polina, for joining us today, for sharing your experience with us, for telling us about your experience doing a PhD and your work. And thanks everyone for joining us today too, and watching us, asking questions. And yeah, have a great week, everyone.
Thank you so much.
Bye.
Bye bye.
Thanks. Bye.